This is not a common occurrence. In this case, there were no human casualties. The catastrophe was not the result of individual carelessness, but it could have been. In a situation with human lives at stake, disaster is a potential, and lives are at stake, even your life, wherever toxic propellants are handled. It wasn't too many years ago when a chemical manufacturing plant or chemical laboratory was the only place one might find such toxic compounds as hydrazine, monomethylhydrazine, unsymmetrical dimethylhydrazine, commonly known as UDMH, or nitrogen tetroxide. In the space age, these have become propellants for rocket engines. Today, these fuels are found in many locations throughout the United States. You'll find them in small or large quantities in industrial plants, where rocket stages or their engines are designed and manufactured. At widely separated test sites, too, thousands of gallons of these hazardous compounds must be handled routinely, but only during observance of the most strict safety precautions. For the hydrazine compounds and nitrogen tetroxide are highly toxic to man. Perhaps the greatest quantities of these so-called exotic fuels are used at NASA's Kennedy Space Center and the Air Force Eastern Test Range. They have contributed to our manned space flight successes. They have played an important part in many of our unmanned space missions. And they will play a continuing role in the space flights of the future. So let's find out what we need to know about these mysterious and dangerous compounds. They're going to be a part of our lives from now on. Neither the hydrazine compounds nor nitrogen tetroxide are new. Hydrazine, for instance, was first used in 1887. However, their application to rocket propulsion is a comparatively recent development. At Kennedy Space Center, monomethylhydrazine and a varying mixture of hydrazine and UDMH are commonly used as fuels, with nitrogen tetroxide as their common oxidizer. All three share 5 common characteristics. First, each is highly toxic to man. This is true whether the fumes are inhaled, the propellant is ingested into the body through food or drink, or contact the skin in liquid form, as in this case. They are hygroscopic. They absorb water or moisture. This means body tissues are vulnerable, particularly the mouth, nasal passages, and eyes, where moisture is normally present. They are water miscible. They mix readily with water. This is your greatest single safety factor. They are insensitive to shock. For instance, they will not explode if dropped or handled roughly. They are hypergolic. That is, the fuel will ignite instantly when it comes in contact with the oxidizer. The primary reason for their use is that they are storable. They do not evaporate or deteriorate to any great degree while in extended periods of storage. However, they should be kept at moderate temperatures. An inert blanket of dry nitrogen gas is used to top the contents of each storage vessel. Non-flammable, the dry nitrogen also prevents contamination which would result from moisture condensation. All containers must be grounded to eliminate danger from static charges. Finally, a method of safely disposing of these toxic propellants when they've become contaminated must be worked out. The hydrazine fuels, for example, are burned in this furnace. Diesel oil provides the consuming flame, and then the unwanted hydrazine is valved into the firebox. This rather elaborate disposal system serves to underline the hazard potential. Don't depend on your eyes or nose for danger warnings. Hydrazine and monomethylhydrazine vapors are not readily detectable by sight, and they have a sharp ammonia-like aroma. However, the hydrazine UDMH blend has a fish-like odor. If you see the reddish-brown fumes of nitrogen tetroxide, be sure you are protected or clear the area. The tetroxide is distinguished by a pungent acid smell. Indeed, in contact with moisture, it forms nitric acid. Any vapor concentration of either fuel or oxidizer higher than 1/2 part per million is considered toxic for prolonged exposure. Yet it must be 3 or more parts per million for any odor to be recognized. Now let's move to the demonstration area where our technician is ready to test the explosive potential of hydrazine UDMH blend. He places the tip of the sparking device into the concentration of fumes. He checks with the safety man to confirm that observers are clear of the hazard. The signal is given, and the scape-suited demonstrator triggers the spark. The reaction in the open air is not violent. However, the hydrazines burn with a very hot, invisible flame. The hydrazine UDMH blend vapor is explosive in any proportion from 2 1/2 to 98% by volume with air. So is monomethylhydrazine. By comparison, the gasoline in your car will fire only in the mixture range of 1 to 6% by volume. A film of hydrazine liquid in contact with rust or other metallic oxides may ignite. Iron, copper, molybdenum, and their alloys serve as catalysts to break down the hydrazine compounds and give off heat in the process. So thorough washdown after each stage of the fueling operation is extremely important. The effects of the hydrazine compounds on the human body by direct contact or inhalation are of particular concern. Liquid hydrazine in contact with the skin or eyes may cause severe burn damages. It will penetrate the skin, causing dermatitis and systemic effects. Inhalation of vapors will cause respiratory tract irritation. The hydrazines affect the central nervous system and destroy the red blood cells. Repeated light contacts may affect the liver and kidneys and cause anemia. Even short exposure causes dizziness and tremors. Long exposure may result in convulsions and death. Because these chemicals are extremely irritating to the eyes, contact lenses should not be worn in a hazard area. The liquid might get trapped beneath the lens long enough to cause permanent damage. The other part of this hypergolic combination, the oxidizer, is nitrogen tetroxide. Since it combines readily with moisture to form nitric acid, the eyes, skin, and lungs are particularly susceptible to damage. In addition to a burning sensation, early symptoms may include coughing, fainting spells, and nausea. Even mild exposure to the vapors can have serious results. If you are exposed to any of the toxics, water is your best friend. Get to an emergency shower as fast as possible and continue flooding those caustics for at least 15 minutes. The pungent odor of nitrogen tetroxide is detectable at approximately 3 parts per million. 25 parts per million will irritate nose and throat and deaden the sense of smell. Thus, it would be relatively easy to become exposed to the low concentration of 250 to 400 parts per million. Lung tissue is burned. blisters form, and the resulting moisture accumulation causes asphyxiation. Your seared lungs cannot absorb sufficient oxygen. If these propellants are so hazardous, why use them? These fuel combinations have a high specific impulse, that is, a high level of thrust per pound of weight. They are storable, and because they are hypergolic, ignite on contact, the need for a special ignition system is eliminated and the engine restart capability is enhanced. To illustrate the hypergolic reaction, a simple demonstration is prepared. An extension pipe is attached to the base of an elevated funnel and swung out toward a stainless steel pan which will hold the hydrazine UDMH blend. A pouring cup is swiveled at the top of the funnel. The cup will contain the oxidizer. The pull wire attached to it is checked and then unreeled to a safe distance. Preliminary preparations are complete. Technicians in scape suits will conduct the demonstration. One will handle the hydrazine UDMH blend, the other the nitrogen tetroxide. As soon as their communications lines are connected, they inspect the demonstration setup and retire to well-separated areas. The first demonstrator picks up a glass container of the colorless hydrazine UDMH blend and prepares to measure the small quantity required. In the other area, the pressure vessel of nitrogen tetroxide is readied. The first step of this test is to load the fuel. You will note that the operation is completed sequentially, never simultaneously, and different men handle the propellants. One the fuel, one the oxidizer. Wind conditions are such that any fumes are carried away from the fuel handler. With the transfer completed, the demonstrator retires. During propellant loading operations, a fire rescue team stands by. Now it's time for nitrogen tetroxide to be transferred to the pivoted cup on the edge of the funnel. It's only because of the small quantities involved that the propellants are placed in this proximity with a crosswind to prevent any mingling of fumes. The oxidizer handler closes the lid on the cup, again checks the wire, and moves back to the safe area. Ready? Pull the wire. Now let's talk about you and your protection. Chances are you won't be directly involved with the fueling operation, but you just might be in an area where a fuel leak or spillage could occur. The pad areas are most likely. The Thor Delta pads, for instance. The Delta stage is fueled with hypergolics. The Atlas Agena pads have toxic fuel loading facilities. All the Titan rockets use tremendous quantities of these propellants. Also, there's the spacecraft static test area on pad 16. And of course, the Saturn spacecraft also utilize the toxic fuels. Area 60A is where propellants are loaded on the Surveyor spacecraft. Then there's the toxic fuel storage area and a separate area for storing the oxidizer. Disposal of detanked or contaminated hypergolics presents a problem. Just dumping this material would result in lasting contamination of the water table or the entire sewerage system. So special disposal procedures have been developed. Those are some of the key areas of potential hazard, but not necessarily all of them. For instance, the Apollo spacecraft are normally fueled at the launch pad. If something went wrong, it might become necessary to detank the fuel and move the entire Saturn V vehicle back to the vehicle assembly building. There, the spacecraft with its residual propellants would be disassembled. Remember that even though the fueling systems have been flushed, toxic quantities of propellants remain. Components might be routed to the manned spacecraft operations building for destacking and further work, depending upon the corrective action required. The hypergolic building in the industrial area at KSC is another site where these hazardous propellants might be encountered. Whenever you enter a known hazard area, learn the locations of eyewash fountains and showers. The Saturn launch pads have many emergency showers distributed throughout the area. With each shower is an associated eye wash fountain to protect precious sight. Water is the first of the two elements provided for your safety. The second is the gas mask. Brightly striped lockers each contain from 5 to 20 gas masks. The masks, as long as they are not used in an oxygen-depleted atmosphere, provide life-saving protection from these toxic fumes. The gas mask lockers, like the showers and eye wash fountains, are located on the service tower as well as in ground-level areas. Escape suits are provided as required to all toxic propellant handling areas. All persons involved in the fueling operation who are required to work in a confined area during the transfer must wear escape suit. SCAPE means Self-Contained Atmospheric Protective Ensemble. It's a sealed container for a man, complete with rubber gloves, high rubber boots, and an integral contoured helmet and face mask with built-in communications. Some suiting assistance is necessary to ensure that the rubber-covered nylon suit offers 100% protection to the wearer during fueling operations. This special demonstration suit of clear plastic shows the tubing used for temperature control of the legs, arms, and torso. The worker is dressed only in a special set of underwear designed to protect him from extremes of heat and cold. His supply of liquid air is hooked up to the distribution system. This air supply system is also known as the manifold. When the suit is zipped closed, he can work for an hour or more in his self-contained atmosphere with complete comfort. Fuel splashes or leaks generally affect a restricted area, while fumes can be anywhere. With prevailing winds from the southeast, the northwest quadrant of the pad may be the most dangerous. Thus, inhalation of toxic vapors is a potential hazard to people in this area. During actual propellant transfer, only essential personnel are allowed in controlled areas, and those in confined areas wear escape suits. The rescue and cleanup crews in the open area wear protective suits. Notice the face shield and hood overlaps the suit top, and the trouser legs lap over the boot tops. This is to make sure no splash will funnel into contact with the skin. A Scott air pack, which is much like a scuba diver's rig, with a 30 to 40 minute supply of compressed air or a gas mask, may be worn with the suit. During static periods, where propellant loading has been completed, controlled access is limited to personnel required to solve problems or assist with the spacecraft. Safety personnel equipped with toxic vapor detectors or sniffers monitor the vapor concentrations throughout the area.
Attention on the complex, this is pad safety. There's been a major spill in the test cell. All personnel evacuate the blockhouse immediately. Attention on the complex, this is pad safety. There has been a major oxidizer spill in the test cell. All personnel clear to the blockhouse immediately.
Go back!
Test cell. 3 personnel have been exposed to oxidizer. Send medical support immediately.
in any accident, prompt action by all personnel included is essential. However, only a doctor may prescribe medication or treatment of any kind except for the washing procedure. Examination later showed the exposure was slight, but the extreme discomfort will be long remembered. No permanent damage was the verdict. With the increasing use of storable toxic propellants, there will be a corresponding increase in the frequency of hazards and the number of individuals involved. So learn these lessons well for your safety and the protection of your fellow workers, for those who fail to learn and those who know but are careless. There may be no second chance.